Okay, guys, I am not here today. I am really sorry. Um, but here we go. You have a test tomorrow, and it's a summative, and you need to know how to multiply and divide rational expressions. So it's true for any fraction, when we multiply numerator times numerator, denominator times denominator. So A over B times C over D is AC times BD. We can do the same thing with this mess. There's a way to be more efficient about it, and there's a way to be a little bit harder. So just like we did in the previous up top here, we said A times C over B times D. I can multiply 24 times 12 to get 288, and I can get x to the fourth y cubed over, and I can do -6 times 3, which is a -18, x squared, y squared. And then I have to start simplifying. So I have to take 288 divided by -18 and simplify that fraction. That's -16. So I get -16, and x to the fourth over x squared becomes x squared, y. And that is what I simplify to. Ooh, I had that there. Nice. So that's what this fraction multiplies to and simplifies to. I get my restrictions from looking at the terms in the denominator. So I set every variable equal to 0, and I solve for the variable. So x can't be 0 and y can't be 0. Some of you might do this a little more quickly. You might look at this as 24x cubed y cubed 12x and put it all over one fraction bar, which totally works. And we do all this canceling out. So what would happen is, since this is all multiplication, how many times does -6 go into 12? -2 times. How many times does 3 go into 24? 8 times. How many times x squared goes into x cubed? That's a 1. And these y's simplify, and that's a 1. So I'm left with 8 times -2 is a -16. And then I'm left with an x times an x, which is an x squared y. So you can do that either way. Both are valid. The next thing we should take a look at is how to divide. So when we divide, remember, we're going to keep change flip. So you can pause this at any time, but go ahead and write this down. And what we're going to do is keep change flip. So I'm going to write that. You're going to keep the first fraction. Change to multiplication, flip the second one. X squared minus 1 goes in the numerator. X squared plus 3x minus 10 goes in the denominator. Now I'm going to factor. So when I factor x squared plus 5x plus 4, that's x plus 1 times x plus 5. When I factor this denominator, that is x plus 1 times x plus 1. I'm doing two numbers that multiply to 4 that add to 5, which is 1 and 5. Two numbers that add to 1 that multiply to 1 but add to 2, that's 1 and 1. X squared minus 1 is that special Ray Webster, that's x plus 1, x minus 1. And then two numbers that multiply to -10 that add to +3. Isn't that going to be a 5 and a -2? So x plus 5, x minus 2. So now, super easy to talk restrictions. Look at everything in the denominator. X may never equal a -1, another -1, a -5, or a +2. And now we cancel exact matches. X plus 1 divides out, x plus 1 divides out, x plus 5 divides out. My fraction reduces to x minus 1 over x minus 2. That's my final answer. Okay, next. Add or subtract. Remember, we need to find the least common denominator. So in most cases, we should factor first. My first term is factored. X over x minus 1 is factored. But My second term is not. I need to factor two numbers that multiply to 2 that add to a -3. That's a -1 and a -2. So this factors to x minus 1, x minus 2. So my least common denominator is the number x minus 1 times the number x minus 2. So I come over here, and this fraction on the left is missing x minus 2. So now what I'm going to do is I'm going to multiply this out, and I get x squared minus 2x over x minus 1, x minus 2, and I'm adding 2x minus 1 all over x minus 1, x minus 2. So since my fractions have the same denominator, the denominators are the same, I can add the numerators. So my denominator is x minus 1, x minus 2, and I'm going to add my like terms. X squared has no other like terms. A minus 2x and a positive 2x go to 0, and then I get a minus 1. Okay? So this should look familiar. X squared minus 1 factors to x plus 1, x minus 1, all over x minus 1, x minus 2. And my restrictions come from the denominator. X can never be a positive 1 or a positive 2. And I can cancel this. So this fraction, when I add it together, reduces to x plus 1 over x minus 2. Okay? And last but not least, this is where we have to factor both. So I'm going to factor my problem on the left. This is going to factor to x minus 3, x plus 2, and I'm going to subtract 4 over, this is going to be x plus 2 times x plus 2. So my least common denominator is x plus 2 times x plus 2 times x minus 3. Okay? So I'm going to go to my first term. He's missing. He needs another x plus 2. He only has 1. He needs another one. So when I multiply this, I get 5x squared plus 10x all over x plus 2 times x plus 2 times x minus 3. I'm going to write my subtraction symbol. The term on the right, this fraction, is missing my x minus 3. So when I distribute that, I get 4x minus 12 all over this same denominator. Ooh, it's not going to let me grab it. Okay. So my denominator is x plus 2, x plus 2, x minus 3. So to finish it off, I'm going to subtract. So I'm going to distribute this negative sign, which means it changes to a plus. That becomes a minus sign. This becomes a plus sign. So I have 5x squared. And then what I have is a 10x minus 4x. 10 minus 4 is 6x. And then I've got nothing plus 12. So this is plus 12. And then my denominators, x plus 2, x plus 2, x minus 3. And the last thing that I need to do is say, what does x never ever equal? X can never equal a -2, a -2, or a positive 3. There's my final answer. Okay? This is up on my YouTube channel. I'll post a link to my website. I will email you guys the review answer key, and just be ready to go when the bell rings tomorrow. Make sure you bring a calculator because I don't have enough for everybody. All right. Have a lovely day. Here's my shout out to Larry. I hope you're awake. My shout out to Amanda. Help anybody who needs help factoring. My shout out to Sam. I hope you weren't talking to David too much. I would like to do a shout out to Sierra. How are you? Katura, help anybody who needs help factoring. Andrew, trust yourself. Michaela, you can do this. Alyssa, Taylor, Sarah, Celine back there in the corner. Go get them, girls. All right. McQueen, Anessa, Christina, Noel, have a good day. See you guys. Bye.